You mean just like seeing it in the background of my video isn't good enough? No, I'm just joking. Let's see. Test. Pretty blurry.
I think it might be the projector.
Yeah, I don't really want to mess around with it.
It should be like an autofocus button. Yeah, that is like.
Yeah. Hmm?
Seems a little bit blurry. Yeah, no, it is quite blurry. Yeah. Fine, that's fine. And the resolution is just awful, or yeah, I think it's blurry. Like, because if I move it in or out, it's gonna help me. Okay. Oh, that's not, that's to fix the angle. Let's see, how do we? AV mute, that's just a screen to cover the. Wait, hold on, maybe let's see the. What do you, AV mute? I think it's zoom. It's not really the zoom, it's the focus. Focus, so yeah, that's true. I don't think there's anything on this. I just have to, hold on here. It's to look up the name of the.
Here. Seems better.
Yeah, that's,
It's sort of where it was.
yeah. Yeah, you can see it up too much, up too much other way. Keep going, keep going. Stop.
Yeah, probably about as good as we'll get it.
Yeah, it's just a pretty low resolution. If you look at the screen, you can just see. Like
Yeah.
those are the pixels.
Yeah. Oh, we're improved at least a little bit.
Control plus everything.
Okay. Um, I think I see some hellos from people in the chat. I don't know. Can you guys give like a reaction or something if you can hear me or unmute and say, oh, okay. Thank you, Michael, NJ, and
I
everyone
hear you.
else. Um, good evening. Thank you, Jayu. Um, good evening, everybody. My name is Ben, and we're here to talk about robots. Um, let's see, I think there was like 5 or 6 people in the chat, and we've got like 6 or 7 people here in the room. So we call that a pretty good turnout where I come from. Let me see if I can figure out how to hide this meeting control thing. Locking all my important tabs. Um, Okay, guess we'll just do something like that. All right. So the topic for tonight is robot operating system, ROS. Uh, my middle name is actually Ross. It's not a joke. It's on my driver's license, but with two S's. But I guess before we get into like the really fun nitty gritty part of this, um, could I get like a sense of who has heard of Ross or has like ever used it or okay, a couple few tentative hands in the room, nothing immediately apparent from the chat. That's okay. That's sort of where I was. I didn't know who Ross was until I was like a senior in my undergrad. I was introduced to Ross at an internship that I did at NASA at the Marshall Space Flight Center in Alabama. It was a project that I was working on that was a robotics project that had been built by previous classes of interns and over the course of many years. And they all knew what was going on with robotics and ROS, and they built this really cool, sophisticated system. And then when I got there, I was like, I don't know what this is. I don't know how to do anything. I don't know how to use Linux. I don't know how to build code. Like my only experience, because I come from the world of mechanical engineering. Um, Also, are we recording or do we need to? Okay. All right. Because I come from the world of mechanical engineering, my only coding experience was like an introductory programming for all engineers class that we like wrote like a hello world and we did a little like calculator thing and it was like kind of pointless. And then I didn't code again for like 3 years. Um, do, do you all code in one language or another or not at all or like a little bit? All right, pretty wide range. So some of it should be like more familiar to those who have used code of some sort. But I think even if you are like a Python whiz or like amazing at using R, like there's a lot of stuff in ROS that's like, I don't know, I would call it just like more like sophisticated practices for software development, where like when you're in kind of like doing an assignment for a class, maybe you just have one really long main file like that's how I did it at least. But with ROS you got all these different source files that are being built together again linked against other packages and repositories and it's all kind of like involved. Fortunately there's a lot of really good resources out there for using it. But before we get into like the actual nuts and bolts of how to do stuff with ROS, we'll talk a little bit about why you might want to do anything with ROS and what it's generally kind of good for. Maybe we could put this over here. So these slides also I can share. On they're on GitHub from a ROS training course that I used to teach at my old job. And I guess also add a couple sentences about who I am. Like right now, I'm a third year PhD student in the mechanical engineering department. Uh, I like to say, even though I'm in the mechanical department, I don't do a lot of turning wrenches. I do a lot more of like writing code. And I think that's true for most graduate programs. Before I was at Rutgers, I worked in industry for a few years at a company in Texas. And when I was there, we used ROS for everything, which was kind of cool to be able to use it uh, in a kind of industry setting. It's becoming more common for the ROS tools to be used in that kind of environment, but there's still, I think, more commonly used in research settings than in industry settings. That is starting to change a little bit. Like it is becoming more broadly adopted in industry, but I think it's generally true that it's considered like more of a research tool or something that you use to build a prototype or a minimal viable product. And if you want to actually commercialize something, you're probably not going to use ROS. But there's companies that take a contrary view to that as well. Um, anyway, the company I worked at was Southwest Research Institute. And when I was there, I taught this like ROS training course to people from other companies or from other schools. So these slides are from that. And all of their training material is on like including these slides. All the material is on GitHub. We can share those resources later on. Um, yeah, so this is like the training documentation for the ROS Industrial, we called it when I was at my old job. But it really sort of shadows and echoes a lot of the general ROS training stuff. Uh, so yeah, anyway, that's a little bit about me. Back to back to the regular programming. And also like feel free to jump in at any point if you have a question about something specific to what we're talking about, or more generally like about my experience working at various places or as a grad student here. I'm hoping this can be kind of like informal and fun. Yeah, we're not gonna have time to go through this whole thing because usually this is sort of like a 3 to 4 hour session to go through this one slide deck here. There's like a we would usually do like session one in the morning, session two in the afternoon on day one, and then day two would be session three in the morning, four in the afternoon. So these are kind of longer uh, programs that we're just going to kind of scratch the surface at the beginning, give a little introduction to why we're doing this and a little bit of how it works. So yeah, we'll definitely get through all this intro to ROS, talk a little bit about ROS workspaces and packages and some of these other concepts like nodes and messages. Before we get into those more technical things, uh, a note of warning. We're going to talk a lot about, or when we use commands today, or probably when you'll do it if you use tutorials, you're going to be typing ROS2 a lot. And ROS2 is sort of like a newer version of ROS. It's become pretty widely adopted. It's definitely like if you're starting a new project, you should definitely use ROS2 because ROS1 is end of life in next year. So that means that it's no longer going to be actively supported by the developers, but it was around for a really long time. I forget if, yeah, it was started in 2008. So like whatever, 16 years ago, and it's still being used today by people. So it's a pretty good tool set, but there were some drawbacks about kind of like security vulnerabilities with it, as well as some other just more architectural issues that we can talk about more if anyone's interested. Anyway, ROS2 basically works the same way. There's some little syntactical differences and some differences in the way packages are are put together and built. But conceptually, things are pretty much the same between ROS1 and ROS2. Okay, so there are some like asterisks to what I'm saying, but in general, if you're using ROS, you should do it on a Linux Ubuntu system. Um, now, ROS, that when you install it from the official documentation, they have instructions for installing on Windows. Honestly, I've never tried it, but I've looked through these instructions and it looks like a nightmare. Uh, it was not built for Windows. They kind of have like hacked it together to work in Windows. So I think the only people that use ROS on Windows are people who are at companies who prohibit them from using Linux. Um, so yeah, I really advise against that and advise to just use Ubuntu, which is where 99.9% of ROS developers use it. Uh, Now, like when I was at my first internship where I encountered ROS, I'd never used Ubuntu before, so that was a little bit of a learning curve, but there's it's not that crazy. Like my computer right now is booted into Ubuntu, and you got your browsers, you got your file explorers. It's not so different from an ecosystem that you might be more familiar with. Um, but it just gives you a little bit more control to lower level operations on the computer, which is helpful for this robotics programming. Also, on that note, uh, in this repository with the different slide decks, right now we're looking at session 1. There's this session 0 as well, that if you've never used Linux before, you might take a look at that for a little bit of a primer on how the operating system sort of functions. Yeah, I'm not going to go through all of that right now, but there's a little bit of information about using the terminal, which is like, this kind of like matrix hacky console looking thing. Some useful commands. So that's just another resource that you can use if you're looking for something like that. All right, back to session 1. So that was all a little tangent to talk about Linux and Ubuntu. Now, Ubuntu, kind of like Windows or Mac or whatever, they have periodic updates to their system, like new versions that are released pretty much every year or two. And the ROS software that you're using is kind of tied to the version of Linux that you're running. So right now, my computer here is running, let's see, yeah, here. So right now I'm running Ubuntu 24.04, which is the latest LTS or long-term support release. And if you're using 2404 like I am, then you need to, here they say, these packages are available for ROS to 2404. So if you're using a system that's older, like 22.04 or something else, you just have to use the appropriate version of ROS that matches up to it. And there's sort of handy tools here. So this version that we're on now is Jazzy. Oh gosh. Oh God. What am I doing? Thank you. Um, yeah, you can just switch to different releases of ROS here if you want the instructions for that. So yeah, different versions of ROS that relate to the version of Ubuntu that you're running on your computer. These slides are a little bit out of date. So the most recent one they have here is Humble, uh, which was for 22.04. The most recent one is Jazzy, as we saw here, for 24.04. All right, so that's a lot of talking without actually saying like what ROS is or does. In general, ROS is just software that you use. It's like code that people have written that you can run on your computer to be able to do useful things, often with a robotic system. And we're not going to get into like what is a robot, but um, for the sake of this conversation, a robot is some kind of computer that's hooked up to sensors to perceive the environment and actuators to act upon it. And ROS is this software tool that allows you to interface all of these different devices and kind of peripheral software tools. So, you know, sometimes it can be confusing. Like, is ROS like, is it like a robot or is it like an operating system or like what? All it is code. It's just code that people have written that you run. Um, we'll skip through that to get like a little bit more uh metaphorical with what ROS is like, or I guess like a little bit more details about it. We like to think of it as consisting of these 4 items here: plumbing, tools, capabilities, and an ecosystem. So plumbing is kind of like the fundamental piece of it, which is the the software that allows the different devices to communicate with each other. Generally, ROS works as a publisher subscriber model where A camera can publish images out into the ROS ecosystem. And if you have another ROS system that is listening for pictures, it can just pluck those out of thin air if they're connected to each other. Um, so yeah, basically, you've got publishers that send out messages to the environment on these things called topics, and subscribers that listen to topics. And if uh, a message is received over one of them, or a message is sent over one of them, a subscriber can hear it and pluck it out and then do something with it. So, for example, you can have a camera that publishes an image as a message on a topic. Maybe the topic's name is color images. And you could have a subscriber that is running like a segmentation tool, like something to block out. If you're trying to detect people, you could have a subscriber that listens for these color images. And when it gets one, it takes the image, runs some internal algorithm on it, um, to locate where the people are, and then can itself also publish new information as well. It can say, I found a person at this coordinate and that coordinate, and then send that to another node that might be subscribed to where are the people. Um, so in that example, we were saying that you could have a camera as your publisher. The reason you can do that is because drivers have been written for pretty much every device you're going to want to use in a robotic system. Um, and these drivers basically uh, translate the native like API for a camera or a motor or whatever into the ROS language. So to be able to communicate over this pub sub protocol, the different pieces of the system need to be speaking the same language. And that's what these ROS drivers do. They sort of translate what might be, a more generic image file into a ROS specific image file. And it can be kind of annoying and confusing because it's like, oh, I already have the image. Why do I have to convert it? But it makes it a lot easier when you have a lot of different pieces that are trying to communicate with each other to have everything kind of on the same protocol. But as you can see here, it's not just cameras or sensors that have drivers built for them in the ROS world. There's lots of things like robot arms or game controllers or servos or all sorts of other things. And if you do have a device that by some miracle does not have a driver already for it, it's not actually that hard to make one. And, that can be a contribution to the open source ecosystem, which I didn't mention, but all ROS stuff is open source, which is pretty cool. Like you don't have to pay to use any of it. Um, and there's a lot of people at, pretty fancy companies that spend a lot of time developing and maintaining these ROS packages. So it's a pretty valuable resource out there that we all have access to for nothing. So it's nice when you build a tool for something you're working on. If you think others might be able to use it, you can just, you know, push it up to GitHub and let people enjoy it and improve upon it as well. So we talked about the plumbing to send messages around, talked about the drivers to enable hardware devices to be integrated with a ROS system. ROS also has a set of tools that help in the development and debugging of robotic systems. So these are things to introspect a system. Like this top left picture is a node diagram. So you can see like, oh, I have one node for my camera and I have another node for my image processing, but they're not connected. Like they should have a topic going between them. What's the problem here? So using these kinds of visualization tools makes it a lot easier to debug those kinds of issues. Um, Additionally, there's like actual 3D visualization tools to see the positions of things in space and look at live data from sensors. Um, yeah, lots of tools like that. Yeah, go ahead.
So like all universities, if you know, like people that use kind of robotics in other countries as well, or is this like a real thing?
Oh no, it's used all over the world. In fact, we can even jump ahead because there's like a slide. This one. Yeah. So like these are all places that contribute to ROS, have published packages. And I think there's even more. Yeah, he's like countries, like the whatever count of unique visits to the ROS pages. So yeah, it's used all over the world. Um, Fortunately, everything's like written in English, so that's good for me. Yeah.
You also like, have you in your experience ever have to do like the level below else, like interacting with whatever you're looking at?
Um, so I guess there's a few ways to answer that question if I understand it correctly. One is I have had to write drivers in the past for like the one that I wrote was for a linear rail that we had for like we had a robot placed on a rail that would then translate, and the robot had a driver, but the rail didn't. So we just had to look at the documentation for the driver, and then it's just we wrote it as like a C++ wrapper for it. It's like a little bit confusing, but I mean it was very simple, so it worked. Um, and then I guess another way to think about like going a level lower is the actual messaging protocol that ROS uses is DDS, which stands for something distributed data, whatever. And that's a standardized protocol. And that was like the biggest change between ROS 1 and ROS 2. ROS 1 had like a custom built homebrew thing from these college kids at Stanford as the protocol. And that worked fine, worked well enough. But if you want to put ROS on like a Mars rover, they don't want like some homemade code from some college kids. They want like an industry standard protocol. So now that ROS has adopted this DDS standard, now they can put it on a Mars rover and have these like guarantees of performance. Um, Yeah, because one of the problems with the old messaging system is that occasionally a message could be dropped or there could be interference between two things trying to publish at the same time. But DDS, that protocol kind of eliminates that issue. And it also allows you to interact with a ROS system directly through DDS instead of through the whole ROS world. I have not done that. I have no desire to do that. But it's like possible. Like there's a bunch of nerds out there that are like really into DDS and they can probably, you know, do really powerful things with ROS 2 that I'm not able to do, but it supports that. Um, I don't know if that's really what you meant by like at a
That's
lower
what it is.
level. Okay. Good question. So yeah, these are the tools for helping the development of a ROS system. And then in addition to those tools for like helping to debug what you're building, there's also like capabilities. Uh, the ones that we use most often are these perception, planning, and execution capabilities. So these are unique from just drivers, which allow you to say, get a camera position, get a camera image, or see like what are the angles of the joints on this robot. Like this actually lets you say, you know, you can use a perception library that exists to fit some 3D data to a model that you might already have scan, and that lets you understand like the position in space of what you want and update your environment to match up with the perceived reality. Planning is a really hard problem. Like if I've got a robot arm and I want to, you know, whatever, pick up something from back here without knocking over my water bottle, it's a hard problem. Like there's lots of ways to do it, but it's really nice that there are some pre-existing packages for doing that. Like it takes almost no effort, basically, which is such a luxury for someone like me who I don't necessarily want to develop a new path, like a new motion planning algorithm. I want to develop a new, uh, for example, a new um, like task organizing system. So, I want to figure out like what order I'm going to pick things up in, or if something's on top of another, do I have to move one thing before getting another? Like if that's my research question, I don't want to waste time figuring out like how do I control every joint of the robot just to do a simple move. So fortunately, I don't have to because there's these capabilities already existing. And then execution is uh, kind of getting back to the lower level as well, in that once you've planned a trajectory, whether it's for a robot arm or for a mobile robot to move around, to actually make the robot do it in the real world, you don't just say go forward. You say like, increment this motor this amount, like this number of degrees. And to do that, you need to send it a voltage of this amount. So it's like a whole, like there's a whole low level control problem there that again, I don't really want to work on. And it's already been solved so that you can so you can actually say just go forward. Um, and a lot of these tools, they're very flexible so that, if you're using, I think this picture here had like a whole bunch of different robots. So like regardless of which one you're using, if you say like go here, it'll just kind of do that. Like you don't have to update all of the planning parameters. Like it's all pretty flexible. Now that said, like I don't want to give you too much of like a rose-colored view of this. Like ROS is as awesome as it is and as powerful as it is, like it's definitely a pain in the ass. Like as anything in like engineering or software or whatever, like it's not actually easy to use. Yeah,
How hard is it to learn?
good, very good question. Um, I think it depends what you want to do with it. Like if you just want to run a system that's built in ROS, it's not that hard to like learn what commands you need to run in what order for something to be able to like move a robot around with a joystick or something. But if you want to build your own packages and like modify things, then it's a little bit more complicated.
You have to learn any additional language. Similar to like languages such as Java, Python, or C++.
Yeah, so that's another good point. So you can build packages in ROS using Python and C++. So if you know one of those languages, then you've got a pretty good start on doing useful things in ROS. Um, also say like when I started my NASA internship, like I didn't know how to do either of those, so I learned it on the job. So I feel like, even if you're not like a pro or at all experienced with a language, um, you can pick it up just by looking at the existing examples and tinkering around a little bit. Um, that said, like I don't want to give you the wrong impression. Like there's definitely a steep learning curve. It's not as simple as just like write your code and run it. There's this whole like building process, which um, is just like kind of arduous and a little bit what's the word, like obfuscated, like
Convoluted.
yeah, just like sort of seems unnecessarily complicated. Um uh yeah, like it seems like why can't I just run my Python script? And sometimes you actually can, but it's really not the best practice. Um yeah.
So when you say you have to write like your own packages, like what would you have to write on it? Like I remember you said you wrote something to move the robot on the rail,
Mhm.
but like what is aren't those like in the pre-built pattern already, or like what is it?
Yeah, so usually like whenever I've worked on sort of substantial ROS projects, um my uh my workspace or like the package that I build, let's see. Like my file structure ends up looking like and we'll get to this later, but we'll say like I'll have this ROS workspace inside of which I'll have a source directory inside of that, I'll then copy in pretty much all of the existing repositories I need. So that might be like a camera driver that already exists. I might need a robot driver. Um, those are just to like interface with the hardware. I might also need like a like image processing package that already exists. So those things I don't need to make. But what I do need to make is sort of like application specific code, which is sort of like in that code, that's where I'm gonna do something like get the image from here, like write a node that takes an image from here and perceives where a person is and publishes where that is. So that's like maybe one node. I'll call that like the person detection node. And then I might have another node that says, so yeah, so I might have like person detection node dot cpp. And then I might have uh maybe I'll call it like motion adaptation node dot cpp. So I can use the robot driver to like plan this motion, or actually robot driver doesn't plan the motion, that'll just execute it. I'll need like a planning node as well. So like path planning is something that exists already, but in this motion adaptation node that I'm writing, I'm going to use functionality from this path planning. Like I'll call a function from that path planning node. I'll say like, hey, path planner, figure out how to get from here to there without hitting a person. And then once you give me that trajectory, I need to make sure that there are no sharp jerks in it so that it's, doesn't uh, error the robot because it's trying to accelerate too quickly. So like the point I'm trying to make is that uh, in your sort of like project workspace, you'll have like a bunch of things that you didn't write, or maybe you'll have to like tinker with them a little bit to get it just right. Like maybe the camera driver, you'll need to like modify the whatever, like the serial number. Like maybe that driver code has to have the serial number for your camera to work. So you might have to go in there and update it a little bit, but it doesn't really need a big change. Um, but really like your application specific code is like the stuff that you're actually going to be writing. I don't know if that really answers your question, but
Oh, yeah, I was just wondering, like in terms of, so you writing nodes is like, how you're using the drivers, essentially. Like you writing the function for what the ROS is gonna do using ROS drivers.
right. And just to be precise with the language, like you're using more than just the drivers, like those are the hardware interfaces, but you've also got these like capability things that we were talking about, like path planning or image processing that you can use as well in your application specific code. Um, it'll make more sense once you're doing it. Um, okay, so that's a little bit about sort of how to build or generally what the ROS system looks like. We talked a little bit about this stuff already. It's really big. There's a lot of code. It's so nice that you don't have to write it all yourself. Um, yeah, so we talked about this DDS messaging protocol as well as the languages that you can use to program it. So in addition to the resources that I'm looking at right now that are available, there's a ton of other resources in like the ROS universe for learning how to use ROS and for like debugging a system once you're using it. Like even like every day that I am working on a ROS system, I'm Googling like, what does this error mean? Or what is like I'm this keeps crashing when I run it. Like what's going on? So fortunately, there's a really robust community of people that contribute to this open source project and are invested in it working and working well. So, they like it when you report something is broken because they can say, oh, like let's fix that so that when NASA's using it or when NVIDIA's using it, like it doesn't break for them. And a lot of the people that build these packages work for NASA or NVIDIA. So they like actually get paid to do it. So a lot of this code is really high quality. Um, yeah, so we can send out some more of these resources after the fact, but the best place to start when doing any ROS stuff is the uh, official ROS documentation. And again, we're on this Jazzy distribution, which correlates to the Ubuntu version that I'm running on my computer, 2404. But yeah, this is where your ROS journey should begin. Um, and I actually took the liberty of uninstalling ROS from my computer in advance so that I could like show you how it's actually pretty easy to install it and start using it. Let me see if there was anything else I wanted to talk about here first. There's the documentation. Yeah, a bunch more online resources. Yeah, that's all that. Um, okay, so yeah, that was like all the intro raw stuff that I wanted to cover. This slide deck here then continues into a sort of slightly more advanced application than what I think makes sense to start with here. But you can definitely feel free to go and look at these slides as well as the industrial training documentation that accompanies it, which has pretty detailed tutorials on, like step by step starting to uh, do this like fake application here, which for uh, this tutorial or these slides is like making a robot pick up a box from a table, which is kind of cool. It's not that hard to get running. I can help you with it at some point if you want to try it. Um, but we're not going to do this right now. We're going to go to the original main ROS documentation and run through a little bit of how to use that. I guess before I jump into that, are there any questions or thoughts, or you guys feeling excited or scared or bored or hungry or should have eaten before you came? um, uh, all right, yeah. So these are the official documentation. Uh, this is the official documentation. The first tab that they have here is for installation. Like I was saying earlier, stay away from Windows with ROS or use at your own peril. I'm no help for you there. Uh, yeah, you should use Ubuntu. There's a bunch of stuff on here. I've like gone through this many, many times, so I kind of like know what all these steps are and I kind of like trust what it's doing. But if you're doing it for the first time, you might actually like read through everything in here. But I guess let me rejigger my screen here a little bit. Uh, so yeah, what you see here in this terminal window was me removing all the raw stuff on my computer earlier today. Can I get rid of that little yellow line? Okay, nice.
Click back on the mouse cursor.
All right. I think we're good. Thank you, Tony. So yeah, installing ROS is not that hard. Once you have uh, Ubuntu available, um, that can be kind of annoying. I've set up my computer to dual boot into Windows and Linux. Um, I sometimes use the words Linux and Ubuntu interchangeably. Um, Linux is like the lowest level kernel for uh, several different operating systems, and Ubuntu is like a more specific uh, flavor of it. But when I speak, I sometimes use them interchangeably, just so it's not confusing if I go between them. So yeah, my computer dual boots into Ubuntu and Windows. I think that's the best way to do it, or that is to say, having a native installation of Linux is like definitely the best way to use ROS. I have, and you can use it through a virtual machine in a Windows or a Mac environment. It can be kind of annoying to set that up, but there are some instructions on this industrial training page. Where is it? Okay, PC setup. So there's some information here about setting up a virtual machine if you want to do that. It can be a good way to sort of get a taste for using Linux and ROS without like fully committing to like partitioning your hard drive. Um, but I use ROS a lot, so I did go ahead and do that. All right, so if you have Linux or Ubuntu on available and ready to use, then installing ROS is pretty easy. You just go to this like installation Ubuntu page on the documentation, and you just go through and you copy and you paste and put your password in. It does a little bit of that, does a little bit of this. Does a little bit of that. So I know this is like kind of boring to watch, but the point is that the actual barrier to using ROS is not that high. Um, like there's a lot of stuff that is confusing and intimidating about it, but once you kind of know how it's done, it's not that difficult to use. All right, hopefully there's not a whole bunch of other upgrades I need. Um, so yeah, when in doubt, always go for the recommended version. Um, so anybody hear any good jokes or questions? Where on here? This thing. Um, so this is so DDS is like this messaging protocol, but there are a few different ways to like access it. There's some open source ways, which is what the default, this like fast DDS is. There are some also like proprietary ways to access that. So like the middleware is that like messaging protocol that is used like under the hood to send information between nodes. And uh, there are several different types that you can use. Like fast DDS is the default one, but we can take a look at this guide for other ones. Um, yes.
How the implementation would be.
Honestly, no, but I have, yeah, I think that some of them have like different, they give you like more access to different parts of like the quality of service, or um, you can like monitor more details about the actual messaging that's happening. I think there are some kind of like edge cases of projects that I've worked on where it's like, this thing is not working with fast DDS. Let's try it with like Open Cyclone, which is another middleware. So it's like sort of arbitrary, or in my case, because I'm not like an expert at like the middleware stuff, it was kind of an arbitrary, like, let's just try this, and it worked. But yeah, so that's I I would say if you're interested, go have fun going down that rabbit hole. But I'm not really an expert on it. You had a question?
I'm sorry, we have a phone meeting, is there not like next week or another event that would be happening?
Yeah, I think that there will be future events like this happening. I don't know if they're going to be on this subject specifically, or in fact, I don't think that they're going to be on this subject specifically. But if you're interested in playing with Ross a little bit, um, you should check out the tutorials and feel free to just like shoot me a message. My name is Ben. You can find me somehow. Well, it looks like it finished installing, so stay for one moment while we test it out. Make sure that it's actually working. So we have to tell the terminal where all the new ROS files are. We'll do our fancy little terminal split thing. And then we can run this demo node, hopefully. So this node is running right now. And now we can see if, gosh, we can see if it's actually working by subscribing to this message that's being published. And oh, look at that. It's actually getting the messages from this talker node are being picked up by this listener node. Ta-da! um, so that's good. So the point of this little demonstration right now is just to show like it's actually very easy to install ROS. You just copy paste all those things and then like it works and then you can do useful things with it. Um, Obviously this is like the simplest thing you could possibly do, but it's you got to start with the simple stuff. Um, One thing that I think is really useful to see and kind of shows some of the value of using ROS are some of the command line introspection tools, which make it easier to understand how, if you got to go, yeah, don't feel bad about it. You're welcome. Yeah, so it's a really useful tool when working on like a pretty complicated spread out system with lots of different pieces of hardware and lots of different sensors and like something is not working, you don't know why. Like just earlier today, I was helping some people with a ROS project and they were trying to get this robot to move around and it just wasn't moving. And my first question was like, oh, is the node running? Is the node for that mobile base, is it running? Is it working right now? And there's a really easy way to check that. You just type ROS or first you have to tell your terminal where all the ROS stuff is. But then you can say ROS to node list. And it tells you there's these two nodes that are running on the system right now, which is pretty useful, especially when you've got like 100 nodes running. You can say like, I'm looking for this one in particular, and you can list them out really easily like that. And you can not only just list the nodes, you can also get information about them. So this is nice because you don't actually have to go into the code to do any of this stuff. You just do it straight from the command line. ROS to node info talker. So it prints out a whole bunch of information about that node. So the really important one for this little demo is this publisher of the chatter topic. And we can actually similarly do a ROS2 topic list. So we can see different topics that are being thrown around the system. And right now it's not that interesting or impressive because there's just a few. But yeah, I've worked on systems that have like easily hundreds of topics being sent around. Like there are some cameras, like these like RealSense cameras that are like to get 3D data. That alone can publish like dozens of channels of topics. So there's a lot of information to be had.
that like the default?
Is what a default. The parameter events and ROS out are like default topics that are always published to like monitor what's going on with the system. Chatter is the topic that's actually being used by these two nodes that are running right now. Yeah, so we can do like ROS2 topic info chatter. And it tells us that there's publisher and subscriber. And we also saw before when we looked at the talker node, we saw that it had this chatter publisher here. Yeah.
So, like, I know can either be, or it could be both, it could be published or but it's not always clear.
Yeah, node can be either or both or other things too. Although ROS usually, or in what we've talked about so far, we've talked about publishers and subscribers. There are also, I think in this slide deck, we get to, like, we're not actually going to get to it later, but there's also like a service, like a server client interface as well, which, like kind of does the same thing, but it actually has like waiting for responses, which the the topic interface where it just sends stuff out into the ROS ecosystem or just like blindly listens for things. There's no like handshake between like making sure that something actually that a message got to where it was supposed to go. So that's why the server client interface is useful. Don't maybe it was in session two. It's okay. There's all this information out there. Um, but uh yeah, so we're working with like publishers and subscribers right now, but there are other ways to send information through a ROS system. Um, okay, so that was the installation here on the ROS page. Let's see this distribution thing. Yeah, we talked about earlier how the different distributions are tied to different versions of Linux. But then the really important part is the tutorials here. So there's a whole bunch of tutorials that I really recommend if you're going to use ROS. You should really just go through these like at your own speed, kind of in detail, understanding every line of code that's going on, because that's really like, watching someone else do it, you don't really get the muscle memory from doing that. But these tutorials are really nice because they start from like really simple. I guess they start off with kind of what I was showing, like those command line tools. Um, yeah, like understanding nodes, um, running a application. Um, yeah, I mean these are all like pretty simple, but they're well designed to kind of build upon each other to reinforce the concepts that are useful, or more than useful, like necessary to use ROS. Um, and then yeah, this like these client library tutorials are where you actually like start writing code. Um, the command line interface or CLI tools, those are kind of what I was just scratching the surface of here with like looking at topics and nodes and running things from the command line. But ultimately, if you're going to be working on a project, you're probably going to want to modify or like write your own code, or at the very least modify some existing code. So for that, you use these client libraries, which is sort of shorthand for like the ROS client libraries. All over when you are using this code, or writing code for ROS, you'll see something like RCL CPP, which stands for ROS Client Library C++. And this code itself is like not terribly complicated. Like you include dependencies, you've got your main function that initializes, and then this spin function basically just uh, keeps this code running continually. Uh, and then, yeah, so you start up this minimal publisher object here that periodically, like when this timer, like every second, I think it runs, or sorry, every 500 milliseconds, um, it'll call this callback, which in this case just publishes a string both to the terminal where it's running. Like that's what we're seeing printed out here is this info message where we see the node saying publishing some string, and the string is hello world plus some number. So this node prints that out to the terminal, and then also importantly uh, publishes that message, like that same string message, on the the published topic, which is yeah, this publisher publishing to this topic here. Yeah.
Are there tutorials to like add new hardware to the robot?
Um I short answer is like yes, like there's definitely tutorials for like pretty much anything you can imagine. Um I think, well, maybe tutorial is not the right word, but there's definitely like documentation for it. So, like for example, like I mentioned the RealSense camera earlier. So if we like Google RealSense ROS2 driver, uh, I think this is the one. Yeah. So there's like documentation for this here. Like I wouldn't necessarily say this is like a tutorial, but they have like example code, and they have uh yeah, like build instructions and commands to run. Well, they've really improved this documentation from the last time I looked at it. Yeah, they show you how to reset parameters. So like I would say I wouldn't necessarily call this a tutorial, but I would also say this is probably one of the better documented um, hardware devices out there because it's used by everybody. Um, yeah, 1800 forks. Um, but I mean, there's other things like what's another device that might be used for a robot that you might want? Like, I don't know, like
Battery.
a battery. Okay, I've never thought about that. Let's see. Um, ROS2 battery driver. Yeah, so I mean, these things depend on the specific piece of hardware. So it would need to be a driver for like your battery. Like, I don't know what this smart battery driver is. Like,
Yeah, like power,
hmm?
like a power.
Yeah, so I think that you would need to, well, whatever the device is has to be like, has to have some kind of like computing element to it. So like, I don't think that a power supply, I don't think that you could have like a driver for that necessarily, because it's not like uh it's got no brain. Like you can't like tell it to turn on or off. Like there's no like data that goes between a power supply and like a whatever it's powering. It's just like the plus and minus. I don't know. Maybe I mean I'm a mechie. I don't know how electricity works. So um but yeah, my I think the main point though is that like if you Google around, I'm sure someone's tried to do it like in ROS. It's just a matter of like figuring out like the right way to ask the question. because like once you use it for a while, you understand there's like kind of some lingo that people like to use.
Like, I guess if you're doing like power delivery across USPC or something, then you send it open. I guess that might be the. Well, I mean, I guess like if you plug in a device, if you USB-C, that's then only what device it is. So I guess there's some sort of data going back and forth.
Yeah,
So
presumably.
like when I can charge my computer and then use the same cable without frying my phone.
Yeah. Although Antonio's a mechie too, so he doesn't know how electricity works either.
I only know because I have like a game console, a Nintendo Switch, and when it first came out, there are lots of horror stories about people breaking the power delivery on their console because they were using third-party charging stations. Because the charging stations didn't know how to work with the console protocol.
All right. Okay. Okay. You've got your credibility back.
Yeah, I don't know how it works. Third party. Yeah, you could. She bought something that wasn't made by like something like the console.
All right. So I think that this is like pretty much where I'm gonna wrap up. Like I'm not going to actually like start writing code or like modifying code right now.
Probably the best, probably not something good for like 9 p.m.
No, I mean, I know, look, we're just getting this party started. We're going all night.
Gonna break out the club soda.
You got something else? Got something a little harder? You gotta have a little inspiration to write code. Um, Tequila, baby. Um,
That joke.
oh, I guess these are being recorded. Oh well. It's okay, we have fun. It's a club. Um, okay, yeah. So I guess like to like kind of wrap up, ROS is just software that exists that people have written. It's not like this like crazy complicated, like untouchable, sophisticated thing. It's just code that exists. Um, there's a lot of really good tutorials out there, a lot of really good documentation. There's also a lot of like really bad documentation, so like take it with a grain of salt. Um, I would if you think you're going to be using ROS for a project, or if you think you're going to like do robotics projects at all in like college or after college or just for fun, uh, if you fit in any of those categories, I think you should take a look at the ROS tutorials and maybe set up a virtual machine on your computer and play around with, modifying some of the tutorial code. It's not that hard, but it is a little hard. So don't get like too dejected if it doesn't make sense or you're confused or like it's amazing that we went through this whole thing and I didn't say the word C make lists once, but now I have. Um, and yeah, no, it'll like haunt your dreams or your nightmares. But yeah, there it is. C make lists, very confusing. Like, what the hell is C make? It's like basically it's just like tells the tells the build system, tells the ROS build system how to put your code together to actually run. Yeah. Um, but honestly, I'd be lying if I told you that I really knew how it all worked. Um, my point is just like it is complicated and confusing. So like if it's not working easily for you, that's normal. Um, one really nice thing about being in an environment like this is that there are people around that have used it before. So uh, feel free to shoot me a message if you're playing around with the tutorial and be like, hey Ben, like I keep getting this like CMake error. Like, do you know what this means? And I can take a look at it and be like, no, sorry, like good luck. Um, or I can say like, oh yeah, you need to switch the order of these two lines. Like sometimes it's as simple as that. Um, so yeah, I mean, happy building. I'm Ben, and I'm gonna wrap it up there. Like,
Thanks for the internet.
You're welcome. Yeah, are there any?
Get out aloud.